it is now time, after the first two keynote speakers, to have a first session of technical presentations, which is a session on ecological impact and design. This session will be chaired by Floris Boogaard. Floris, are you there already? Floris is a lecturer at the Hanse Hogeschool in Groningen. Yes. With his specialism in climate adaptation and spatial transformations. Floris, I think you also have a presentation yourself, but perhaps yes, you can introduce yourself to the group, and then let's get this session on the go.
Okay, thank you so much. My name is Floris Boogaard. I'm a professor at Groningen. I'm also affiliated researcher at the Global Center, which was in the presentation of Arnoud Molenaar. I think as a chair, we have a very exciting session with 5 presentations, presenters from Israel, Australia, and the Netherlands. So, of course, as introduced in the beginning, it's about ecological impact and design. I will be the first speaker, so I might just start and then want to share my screen. And I will give you a first slide as a short introduction and for this. So, all right. Sharing my screen. So I hope you will see the presentation. So this is the first slide. So we know where we are in the conference, of course, ecological impact and design. In the right top corner, you see already addressed by Rutger. And what is very nice, there were already 2 questions by Robert and Joost, as you see in the right bottom. And I will, of course, urge you to ask questions about this topic, and also the speakers in the next sessions, and of course the next speakers in this session. I hope they will address maybe answers to the questions of Robert and Joost, because this seems to be a very important topic. No further ado, I will start my presentation, which is basically about the relevance of climate adaptation platforms for floating urbanization and nature-based solutions. We chose this case study in Indonesia. I will explain in a presentation later. I've done this research, or actually very short workshops with results, with Henny Prativi and also Pa Imam, Rui de Lima and Erik de Boer from universities in also Applied University of Groningen, and Indimo, last presenter in this call. Maybe just because I'm a chair and you're stuck with me for an hour, I will explain where I work. So Groningen in the high top. Also the Global Center has an office there. Global Center also has an office in Rotterdam, as Arnoud Molenaar explained. And I'm also a consultant at Deltares. And basically we do this because to connect the professional practice and education and research in this fields. And we saw a lot about Rotterdam already, but also the other regions, of course, might get flooded if the dikes would break. So you will see that this is a very important topic. And without the dikes, I need a lot of floating offices, so to say. So my introduction was this. I will tell you about climate platforms and climate scan in particular, where floating infrastructure is being mapped. We will talk about some workshops in Indonesia and end with some conclusions. I think the first slide shows the challenges in urban climate being addressed by the keynote speakers, Rutger and Arnoud, of course. I'm just stressing that for this workshop, especially in Indonesia and the Netherlands, we address the challenges of subsidence and floodings, and of course also drought and damage in this case. So basically we talk about sinking cities, which there are a lot, of course, a lot of them in the Netherlands, but also outside, of course. You see here Jakarta, Indonesia, but also other places like Semarang and Surabaya, where we did the workshops, and also, of course, Rotterdam being addressed, but a lot of places around the world, as you might see. I will take you to Semarang City, one of the places where we did a workshop to see what the attractiveness could be for floating urbanization here. And of course, the reason for that is the land subsidence being 5 to 10 centimeters a year, which is quite high, even higher than in the Netherlands of most places. And they have an increased sea level of 3 millimeters a year. You can see from these figures that land subsidence is a very big issue here. Seeing also at the photos, these are regular floodings. They're making polders up there. So it seems a logical choice to maybe implement nature-based solutions, but also floating infrastructure. Nature-based solutions, there are about 1,000 different nature-based solutions you can place in the urban areas of Semarang and cities around the world, of course. This is not, it was the topic of the workshop, but not being addressed in this paper, so I will skip that part. But if you're interested, there's a paper about this. So floating infrastructure in Netherlands and Indonesia, we've seen one of the greatest floating structures, maybe the floating pavilion in Rotterdam. I come from the Amsterdam region, so I have to show Eiburg, of course, where more than 100 floating houses are together in one district. It's quite compact, and of course there were a lot of questions about ecological impact on that one, being addressed in the last speaker. Then, of course, also left corner, floating mitigation options, so floating solar. This is one of the biggest, actually the biggest implementation of floating solar in Europe. This is the Bomhofplas in Zwolle, 18 hectares of floating solar. So you can imagine that there are a lot of questions on that one. And on the right side, you can see some implementations in Indonesia, a floating library, but also a floating restaurant in the area of Semarang, which has been mapped in this study. They have been mapped for the use of sharing knowledge, of course, and climate adaptation platforms. You can see here a bunch of them are being used also for floating urbanization and nature-based solutions, knowledge exchange. And there's a clear demand for this. You can see that most countries have their own platform. There's some global. One of the global one is Climate Scan, which is hosted from the Netherlands and has a lot of examples on floating structure and nature-based solution. Just to show you a map, it's open source, more than 5,000 projects been mapped. You can see Asia, quite high number, also the Netherlands or Europe for that reason, and also Australia and Africa. There are a lot of projects. On floating projects, we'll show some later. The platforms, this is the biggest platform showing climate adaptation mitigation. Why would that be? Well, basically because it's one of the platforms that it's open source, meaning it's citizen science. So people, as you researchers or just people working in practice can upload your projects around the world. It's free. There's no registration cost. All photo and film material can be used in research publications. It provides detailed information, but the main information is which location it is, because that was the main focus. People want to know where these projects are situated, where can they visit it, maybe talk to stakeholders and see if it's a good implementation for their practice as well. It's interactive, linking to social media, a lot of international projects, and it links to scientific research. So most researchers that use this, also researchers from this conference, will upload their papers to that specific location. So if you go to the floating pavilion in Rotterdam, for example, you will see some research papers connected to that dot. And of course, I can't stress it enough, it's citizen science. That's the success maybe of having more than 5,000 locations, but also sometimes it's just a dot on the map and having not a lot of information. And that requires, of course, quality evaluation. So this is the map. I showed you this. There are over 1,000 registered users and rising that upload projects around the world. So that's quite nice. Topics are water, but also heat or biodiversity. So it's quite diverse. It's more on the level of nature-based solutions than floating urbanization. But of course, that meets the goals of mitigation or not. So if we focus on the Netherlands, on the left corner, there are about 2,500 projects on nature-based solutions. Of course, also floating urbanization. On the right, it's Java, about 100 projects, mostly on some of floating urbanization, nature-based solution, but also one of the challenges is water quality improvement. So a link to ecological impact. These are only floating urbanization. It's one of the categories. If you go to the legend, you can see push that legend, and then you will see only floating projects. So that will be in Europe, Netherlands, for example, of course, and then in Asia as well. And if you zoom in, you will find these structures. So in the Netherlands, there are over 40 locations where housing districts are implemented, floating housing districts, but also floating glass houses, the floating pavilions, of course, there. So you can see it's quite widespread, and that's without houseboats, for example. Otherwise, it will be a total map of the Netherlands, so to say. And there's some projects in Indonesia, mostly in Semarang, that have been mapped. And that was the reason also to maybe focus more in a workshop on, can we upscale this? Is this a good idea? Is it attractive for Java or Indonesia as a whole, or Asia? The map projects that you can visit, as been said, it's open source. There's a floating library, which is quite nice and being visited, and therefore also raising awareness and having information getting across to young professionals and all people that visit the library, of course. Floating restaurants, most visited, great food. I've been there. And also some other projects that you can visit in this case. So it was a reason to come up with a workshop, because 2 locations, are there maybe even more, or what is the enthusiasm of people for this floating urbanization? Seems quite logical for Indonesia, of course, being the land subsidence and floodings that we occur. So here are the characteristics of 2 workshops. We did Semarang and Surabaya, and of course before and after the workshop there were a lot of pre-meetings, and basically it's about the sustainable development goals that you can see here. So climate action, sustainable cities, and of course innovation in infrastructure. So one of the topics that are not addressed as well is the attractiveness. I think we are all in this conference for one reason, and we see the benefits, as been explained by Rutger as well. But is it attractive? And we wanted to know that by the workshops. And to our actually surprise, was floating urbanization the least popular option from all options given here. And you cannot compare the different options. Some are related to nature-based solutions, but they all are a solution for frequent floodings. And it could be pluvial floodings or tidal floodings, of course, but also flood barriers were presented in this study as well. So this was a bit of a surprise. And of course, we dive into the different reactions that we had from floating urbanization. And it had mostly low scores because they did not find it very accepted in the practice. So culturally accepted in this case. Most things that were mentioned was that it's synonymous with humid, dirty, wet conditions, mold on the walls, and pollution, basically, because of, it could disturb marine ecosystems, which is the topic of this session, of course. Also, if you would place floating buildings, one of the things, issues to be raised, that of course it should be equipped with sewage and sanitation treatment systems, which will have higher costs on floating structures than on the land. So there was a clear need for innovation to have cheap and easy to build and environmental friendly floating infrastructure that's attractive to future residents. And of course, as researchers, we come up with new practical implementations for that. Overall, the workshop, because this was, of course, one element of all the workshops being also addressing nature-based solutions. This workshop, of course, raised awareness and capacity building. Mostly young professionals were attending these workshops. And you can see that especially these climate platforms could be used, and especially because they're easy to use, open source, citizen science, that people are using it and they upload a lot of projects. And that's, of course, only the impact that you have with the workshops. But also after the workshop, we had quite some impact in local newspapers, speaking the local language. So we addressed the issues on floating urbanization, also nature-based solutions. And I think that tapped into one of the points of Rutger's first presentation on the governance part. Speaking the language of people and also relate to the people before you implement it. Also being said by Arnoud, of course, addressing what do local residents feel about the implementation of a water square, but also, of course, on floating urbanization. So coming up with conclusions. I think this exercise was successful in the sense that we mapped a lot of floating structures that you can find on Climate Scan, of course, up to 150. That's, of course, in Indonesia, in the Netherlands, but also the floating airports in Japan and floating houses in Manila, for example, that can be used by inspiration for other projects. The workshop raised awareness and contributed to capacity building. It had high scores on nature-based solutions, so we will do more projects and research on that. Floating infrastructure showed low scores, but still we have some challenges there to make it attractive in this special region, because it's of course locally depending how attractive it could be, and of course on the design and everything. So I think especially raising awareness would be one key element to use. So we're looking for attractive, cheap, easy to build and environmental friendly homes. We will study materials, especially with Inisula, with Pa Imam, and new projects are set up. And I'm very happy with this conference, of course, having a network that could join us in this quest for implementation of floating infrastructure in a very good manner that residents really would be enthusiastic about this. And of course, BMPs are being studied and mapped on Climate Scan. It would be great if there are more than 150, of course. And that's one of the reasons that we also joined this conference, to see all the different projects that will be presented, and we will place them on the map. And I will encourage you to do that mapping yourself as well, because you're the one that having all the knowledge of these different platforms. So that's where I end my presentation. I hope there might be some questions for this, and otherwise we proceed quite soon to the next presentation. Okay. Hope I'm back. Okay, so let me see if there are any questions. I don't see any questions. So maybe we can slowly proceed then, because I don't see questions in the backstage chat. Maybe, wait, no. Okay, so maybe I can invite Iona Giguru to the stage at this presence with a presentation about floating cities and equitable crafting onto marine ecosystems. That will be, that's pre-recorded. So I will ask the pre-recording to start and press the blue button for that.
Hello.
Thank you. Stage is yours.
Hello, thank you for the introduction. I'm Joanna. I'm a researcher with CCDs, a PhD researcher. I'm going to share my presentation as a video with you. So I'm just going to share my screen now. Okay, so I'll play the presentation, and then I will be around for a Q&A.
Hello and welcome to this short presentation about floating cities and equitable grafting onto marine ecosystems. Equitable grafting is a proposal for a conceptual approach towards identifying design directions for future floating solutions which enhance the relationship between urban systems and ecosystems. This research aims to explore ways in which urban and environmental agendas could be better integrated by using the concept of grafting as a base criteria which shapes how we think about cities and urban design in relation to nature. In biology, grafts are used to create hybrid species by establishing new symbiotic relationships, while in the medical field, grafts perform the function of healing, being used primarily to repair damaged tissue. So, if we look at current land-based city systems through the lens of grafting, we can see that although cities rely on ecosystems for services, food, energy, and shelter, the urban and ecological systems compete in terms of land and habitat use. The relationship is not equitable in the sense that the ecosystem is providing positive inputs while cities only offer mitigation of negative outcomes derived from urban growth. By comparison, a city functioning as a graft would aim to support ecosystem growth by sharing resources and enhancing ecosystem resilience and productivity in order to maintain positive feedback loops between city and ecosystem. So in thinking about floating cities as new urban typologies, there are opportunities for shifting towards a more equitable relationship between eco and urban system, and ultimately towards a more holistic response to climatic challenges. More concretely, by looking at the basic parameters of location, scale, and mobility, I'll look at a few examples of how the concept of grafting could be applied and what the benefits of this approach could be. Firstly, strategic siting at the intersection of human and animal migratory paths between, for example, global migratory bird flyways and locations where human populations are displaced due to climate change could provide various benefits for both urban and ecosystems. On the one hand, floating solutions could offer additional space for displaced populations, but also, for example, through the integration of floating wetlands, they could provide additional feeding and nesting areas for threatened migratory species. Especially in the case of migratory birds, current research shows that these species play a key role in supporting local food webs and implicitly the human communities that rely on local fisheries and other ecosystem-derived services. Secondly, siting near existing wetland ecosystems which are under strain from sea level rise and urban growth can enhance urban resilience via increasing the chances of ecosystem survival and making use of the wetland's natural coastal protection function. The provision of additional urban space via floating solutions would decrease land area demand and implicitly decrease competition between urban and ecosystems. Additionally, development sites can be strategically selected to affect water speeds and increase sediment availability, thus supporting faster wetland growth relative to the speed of sea level rise. While in urban design, we often think at the global and regional scales, ecosystems work across scales from micro to macro, and in terms of climate adaptation, micro and local scales often have significant impacts on determining overall rates of survival. Therefore, floating designs which work across multiple scales could provide opportunities for enhancing local biodiversity. At the microscale, surface topography and light availability below the floating structures can be engineered to support marine food webs by providing habitat for plankton and coral species. For example, some studies have shown that floating artificial surfaces with diverse microtopography perform much better in terms of establishing habitat for plankton and corals, which ultimately form the basis of marine food webs. Recently, studies on ecosystem adaptation suggest conservation and management of microclimate areas and localized climate refugia as potentially productive approaches to increasing ecosystem resilience. On the other hand, several studies document positive, albeit unintended, environmental impacts of man-made aquatic structures. An example of this is the rich ecosystems which are developing around abandoned oil rig structures. So at the local scale, expanding design and planning areas to include zoned resource sharing and cultures of endemic species could aid to create biodiversity hotspots which function as man-made climate refugia. Lastly, in terms of mobility, flexible modular floating structures can aid to minimize overexploitation and optimize resource use. For example, a 2015 study found that using marine crop cycling in cycles of approximately 6 years resulted in significant improvements in the biological and economic performance of sea cucumber fisheries. Using the intrinsic flexibility of floating structures, future cities could change their location and functional zoning to allow for crop cycling. Seasonally, the floating structures could also be reconfigured to serve various functions such as crop nurseries, public spaces, breakwaves, or alternative transport routes. This would optimize spatial and functional zoning and decrease urban footprints. Coming back to the main goal of exploring how an equitable grafting approach can help to better integrate urban and environmental agendas, the analysis of location, scale, and mobility provides a few examples which highlight potentially positive environmental impact and symbiotic relationships that could be achieved. At a broader level, the main aspects determining equitability were expanding design criteria across disciplines, identifying common points between urban and environmental agendas, working across multiple scales, and harmonizing functional and natural cycles. While some resulting design considerations are already reflected in existing frameworks, other aspects such as urban design for migratory species are not part of current design considerations. Conceptual approaches such as equitable grafting could therefore play an important role in forming a holistic approach that will enable future cities to become productive partners in the relationship with their natural environment. Thank you.
Okay, thank you very much. Hopefully you all heard it. The audio, yes?
Yes, I think it was quite clear, and I think a great concept. Thank you for presenting this. If there are any questions, please feed the chat. I saw that I missed some questions of the last session, but as Rutger said, we can take them up in the closing discussion. So for Ioana, I hope I pronounced your name right. Any questions? If not, I think maybe from my point of view, I think it's a very interesting concept where you well thought of the theme of this session being impact on environment, of course. What would you think would be necessary to implement this concept in real life, so to say?
Yeah. So I think the examples I was trying to look at are sort of a little bit more practical, let's say. So I was the whole idea was to kind of try and think if we actually integrate this into our way of thinking as designers from the beginning, from the vision, how does that impact then the result of the outcomes?
Yeah, exactly. And what would be the next step to maybe put this into implementation?
I mean, I think there's a lot of other points to be made and kind of developed at a more technical level. So, for example, if you think about it as a kind of potential planning framework, let's say, whereby there's a set of rules that can help you to implement these kind of solutions, that would need more development, technical development.
Yeah. Exactly. And I think during this conference, we probably hear some interesting input to help to develop it and probably connect you to some stakeholders. As Arnoud Molenaar said, he's very enthusiastic about implementing a concept like this and other cities around the world, of course. So I see no further questions. So if you have questions, we still have time. So please put them in the chat if you can. So I think what I like about it is a flexible form, and you addressed, of course, the issue of sunlight not entering the water being an issue. 2 questions, of course, already in the morning session being addressed on that. So maybe you can elaborate a bit more on that topic. What could be the impact if no sunlight entering the sea or waters?
Yes, yeah. So I'm not an ecologist. I'm an architect, but so as far as I'm aware, it depends on the scale as well of the intervention. So if you have a neighborhood that's shading part of the area, it might not have such a big impact. But if we are thinking about a floating city, which is quite a big area that would be shaded, then it would certainly have a much bigger impact. So, which is, I think, potentially where a combination of designing the materiality of what is actually floating, and potentially thinking of how you could reconfigure areas within time to allow for cycles in order to minimize impact, is perhaps a way forward in trying to think about how to resolve this.
Yes, I think that will be a good way. Yeah, perfect. And of course, in the last presentation, this will be addressed as well by Rui de Lima. So one more question from Rutger de Graaf. Are you considering if the concept could be reduce wave energy and protect coastal communities against flooding?
Yes, yeah. So that was actually one of the points that was made in the presentation. Is I was sort of arguing for the fact that there's an overlap between the sites where we could potentially build new floating developments and sites of existing wetlands which are playing a role in protecting the coast and are under threat. So the idea is, can we actually somehow engineer how the floating structures will affect the sediment availability, the water speed in the area, so that we are actually supporting the growth process of existing ecosystems, which are helping to protect the coast.
Yeah, perfect. I think Rutger is very satisfied with this answer. So thanks a lot, he says. So that's great. Okay, I think slowly it's getting time, so maybe we can move on to the next speaker. Thank you so much for this presentation, and I really hope we can implement this concept after the conference. So then we move on to Jörg Bouwmeister. That doesn't sound Australia, but he will present from the evaluation of aquacultural Simanta floating coral reef. So I hope you can get on stage to present this this concept. This also will be a pre-recording of 12 minutes and a half to be exact. And there you are. Thank you for joining us, and I will give the floor to you.
Thank you very much, Floris. And sorry for all these strange first names here. As you see, we have the same background, and the reason for that is that we are both part of a CCTS group. The reason why I'm sorry, I have to now it should work. Sorry, not really. I can tell you also for 20 or 15 minute stories, but I prepared a presentation, so therefore this should work. No. Okay, that doesn't work. So therefore we will play a pre-taped video, and then afterwards I'm very happy to get some nice questions. Thank you very much.
So they're working on getting the presentation going.
I can just tell a little bit more about CCT. So we are a group of around 20 people. Joanna is one of our excellent PhD researchers, and we are sitting at Gold Coast with 500 kilometers water frontage. So I don't want to compare that, of course, to Rotterdam, but we are quite well equipped in terms of water access. And we are part of the Griffith University. So we are since 1 year.
Sorry to interrupt you. There's a play button you can press, and then it will start the presentation. Do you see that in your screen? No?
No.
Then we continue as this, but if there is a play button, please press. Otherwise, we continue like this. Thank you.
Sorry, Joanna is better perhaps than me. We don't have to wear any masks because we almost don't have any cases. So everything is illegal. What is happening here? Okay. So now the organizers, which are doing a fantastic job, thank you very much. They are ready to play the pre-recorded video. Hello, my name is Jörg Baumeister. I'm from Griffith University and I'm the leader of the CCT's Research Lab. And we are located here at Gold Coast, 500 kilometers, canals, wonderful climate, and also lots of water, as you see. The CCT's Research Lab is based at Gold Coast. As you have seen already, we are developing aquatic solutions and redesign coastal cities for sea level rise. And we are merging the expertise of engineering, architecture, and urban design, urban and regional planning, and other environmental science. We are very, very interested in promoting the term of aquatecture further, which is, as we are transdisciplinary, but it's also system-based. We are just demonstrating here one small test round for aquatecture. And we don't have to go deeper into the problem statement. I think a picture is worth more than 1,000 words. So therefore, we have the following research question. Can aquatecture provide ecological and economic solutions to supplement ocean conservation through the design of a floating artificial reef? Or how can a floating coral reef be created to adapt automatically to sea level rise? We worked on something which developed towards a structure which is somehow related to the form of a manta, and therefore we are calling it a sea manta. And I will present you now the sea manta, which is a floating dive and recreation structure, which is half above and half below the water. Above the water, we have hospitality facilities, dive facilities, swimming pool, interactive aquariums, and underwater there's a floating artificial reef and dive experience areas that can be enjoyed. We were very, very keen on developing the form just on science-based criteria. So the first step is to find the right typology. And so these three sketches, they show that normally there's a natural reef, which is on the bottom with the corals. In the middle, there are already floating nurseries working very well. So, and therefore we said, yes, then it would be a logical next step to develop a floating reef. And in terms of the question, what kind of structural typology should we take? There are, of course, vessels in terms of floating structures and pontoons. And we were combining both to semi-submerged floating structures. The next step was then to take the right environmental-based criteria, and we had a request from the Middle East and the Arabian Gulf, and therefore we were taking this specific wind and wave conditions, and with this conditions we were developing a very, very specific form. So if we would put a structure somewhere else, then the criteria would change and therefore also the shape. For example, if there would be an environment with more waves, and then the whole structure would be much more stable. But in the Arabian Gulf, there's just once or twice a year a storm, which is called Jamal, and the rest of the year it's very, very quiet there. So what we were doing was we were starting with something which first adapts to the water current. Underwater, above water, it is also adapting to the flow of the wind. And then, because it's a coral reef, we were not just cutting the middle out something to get more sunlight from the top, and then to have corals below in the water. But then we have also this wings on the right and the left-hand side, which are also providing more sunlight for the artificial coral reef. We were, of course, digital simulating, but also physical. We had various models, and we were going through several rounds of optimizations in wind tunnels and also in our flume tank. And we were putting some functions which are related to the floating reef. So first of all, we found out that there's a specific electroaccumulation called a method to grow corals faster. So we were taking that, but then we were also having an aquatic nursery for fish and for corals. We have also a fish attractor. This is in the central part of this object, and with 2 different rings, one on the depth of 12 meters, the other one 18 meters. And the reason for that is that there we are just having air bubbles which are attracting fish, but also, of course, for the dive experience. This is something very, very specific. This structure is anchored, so the orientation changes all the time, dependent on wind and wave directions. The construction we were developing is a space frame structure. It can be prefabricated, and it's about 60 meters long. It includes a boat mooring. You see that on the right top. Then glass platforms, breeding aquariums, then also displays, pools, a paddling pool, and then in the center, the round thing is also a diving pool, so you can get up on the staircases and dive then through this diving pool, and then you're underwater and you can then get access to the rings or somewhere else. Then we have, of course, event spaces, research facilities, and then also underwater displays, and of course the most important thing, our reef. And here's a section, horizontal section through the reef. We have on the top, on the bottom, that are these 2 wings with reef, but then also in the center part, which gets also sunlight from the top, as shown before. And then we have also in the center this strip. this glass bottom strip with the different aquariums. So you can look from top through the glass bottom into the aquariums and into the different displays. And then this glass bottom is developing into a small pool, and then it ends in this dive pool. The structure has also float tanks. Because it's a semi-submerged structure, it needs also some buoyancy, and this float tanks can be stabilize the whole horizontal adjustment of the structure, but also we have an additional stabilizer which is then linked also to the anchor chain. And we have a jellyfish cave here and other areas where fish can develop a kind of a new or where a whole ecosystem can be developed. So the reason for the size is that our marine ecologists, they said that it can't be reduced because then the ecosystem wouldn't work as good as here. So you see here now what a diver would see, perhaps a little bit lower than 30 meters, but anyway, and you see the rings there with the bubbles. There's a detail on the right bottom page. And the interesting thing of architecture in this case is that there's quite a difference between the part of the structure above the water and below the water. So here we can see now the facilities which could be used as exhibition spaces, but also for events and so on. And you see again this glass bottom, first mooring, glass bottom, and then pool, and the stairs up then, and the diving pool. This is the elevation now, the top part, which is shaped due to some aerodynamic experiments and improvements, and of course it can be also enlightened at night. Yeah, that's it already. We were a team out of myself, and in this case I would call me an aquatect, and then Nikki as a designer, but then different people from Griffith University, but also with an industry partner who's interested in building that. The result is therefore, yes, coming back to the research question, yes, aquaculture can provide ecological economic solutions to supplement ocean conservation through the design of floating artificial reefs. And yes, floating coral reefs can be created which adapt automatically to sea level rise. Thank you very much, and thanks for listening to the outcome of the small test round.
Yes, we are back. Very impatient, me too as well. So you get a very great compliment, very cool, innovative design by Bart Roefe. We have time for one question. Benjamin Kasper asks, how do you organize the energy issues? Do you need electricity or hydrogen? What do you think?
Yeah, great question, Benjamin. Yes, you are on the right track. And one of our team members is here at Griffith responsible for the production of hydrogen, and our university is the largest hydrogen producer in whole Australia. So of course we are very, very keen to test that also now in the water, either with normal LEDs or of course, because in the end the design is geared for the Middle East, we would be also very interested in organic LEDs. Yeah, so yes, completely right.
All right. I hope that's a satisfactory answer to Benjamin. Maybe the last one, Michael Borg. What is the location considered for the floating artificial reef shelter from ocean waves?
Yes, it is not for Australian waves. It is not for Atlantic waves. It's for the Middle East, for the Gulf, which is sometimes called the Arabian and sometimes the Persian Gulf, depending on the political direction you are taking. So, but it is in front of the Emirates and Qatar.
All right. Well, thank you so much.
The whole climatic situation is completely different. Yeah. So, yeah.
All right. Well, I think the time is up. Thank you so much for this interesting video and concept design. We would love to see that in practice, of course. And I hope this conference will help you with that. So then we ask Ido to the stage. Ido Sella from Israel, from Econcrete Tech, with a presentation about eco-engineering for climate change floating to the future. Thank you for joining us, Ido. I will just give you the stage.
Thank you, Floris. Hi, everyone. My name is Ido Sella. I'm a marine biologist by profession and specializing in ecological functioning of coastal and marine infrastructure, operating currently as the CTO of Econcrete Tech. Today in this talk, I'm going to touch basically basic aspects that we're dealing with as we approach ecological engineering of floating structure. I will present some study that we did a few years ago about the specific forces that are dictating the biology to develop on floating structures. And I will touch aspects that need to be addressed in ecological engineering of those structures. Just as we go forward, so a little bit about floating structures. Currently there's very limited knowledge on species assemblages developing around stationary floating structures. When I'm saying stationary floating structures that are anchored on site, that are not are not, let's say, ocean going or have a dynamic propulsion. And we address those and we're trying to find a comparable ecosystem so we can use it as a reference for that. And there's a very limited natural habitats that can be comparable. We're talking about kelp forest, some algae that are anchored to the bottom and then floating to the surface, and of course floating units in the water that accumulate different organisms that are very specific to floating structures. All of them are mostly filter feeders. And basically, we're at the point of understanding that floating structure create a novel habitats, which is it's not comparable to other habitats that we can, natural habitats. And specifically, as there is a spread of floating structures, they're going to be utilized in ecosystems or in places, geographies in the world that doesn't have any reference to a floating natural habitat. And what they do is basically bring in significant amounts of hard surfaces to be colonized by sessile communities. And later on, there's a community that's developing there, and then there are fish and other motile organisms that are utilizing this habitat. Communities in floating structure, and this is what I'm going to run through in a minute, are basically dictated by hydrodynamics. Loads of winds, waves, and other forces that are affecting stability and the body motion of the structure. Taking into account that the vast majority of floating structures are currently constructed by concrete or steel, and this is also, as we look forward for a large floating structure, that's probably going to be the materials of use. We also address specifically those substrates. So just where the study started. The idea was to evaluate how basically benthic communities, sessile communities, are affected by the substrate stability. It was a part of a PhD thesis of Dr. Perkel Finkel. And during that time, there was basically a large area, an experimental area, testing and evaluating units which are fixed and floating, and comparing the hydrodynamic condition on them and also the biology developed on them. The idea was to identify a habitat where we can do side-by-side fixed and floating structures and do an analysis of the forces working on them, and of course connecting that to the biological community that develop on them. It was a very simple experimental area. So what we did is we used boxes with plates in them in different orientations, and I'm going to touch it in a minute. Same boxes were fixed into an oil jetty in a depth of between 27 to 30 meters. And nearby, the same area was floating on a buoy, so an anchor to the bottom. And there was evaluation both of on the different depth in the area of assessing the hydrodynamic forces and also the biology that developed, and also, of course, comparing between the fixed and floating structures. Some of the aspects that were evaluated was mass transfer rates and the current velocities. Was done by cloud cards, and we checked the difference between fixed and floating installations. How within the water column this is changing between the seabed, the midwater, and the surface, and also the orientation of the substrate within the unit. There was video photography to evaluate movement and frequency and amplitude, velocities, and of course shear stress. And for shear stress, we also, excuse me, something is stuck. Okay. With shear stress, we also use what's called strict lines. So we actually created those fuzzy plates that were and attaching small feathers to the structures underwater, and video photographing their behavior in order to identify the laminar or turbinal fluke. Something is stuck. Just a minute. Okay, sorry for that. At the same time, what we did is evaluate biological aspects and the performance of biology and how basically corals are recruiting and biology is recruiting into the substrate. So I'll fly really fast over the results because I don't think they're more important. What is important is that everything is accessible in peer-reviewed papers. But what we found, for example, that there's floating structures are getting higher mass transfer rates in terms of currents than fixed structures. The shear stress on the surface of those structure is different, and it's a very steady on fixed structures, but on floating structures it's unsteady one. We found that within the water column, currents are behaving differently on the surface of structures that are in the water, both fixed and floating. And also, which is really important, we found that the biomass is different. So the biology that developed on floating and fixed structures is different, with floating structures showing much more biomass than fixed structures. That was also true for other aspects, but for example, for chlorophyll and for the amount of algae, fixed one actually had much more algae than floating ones. And in this, because it was coral environment, we also checked the coral sediments on them. And what we found, for example, the floating structures recruited less corals than fixed one. And just summarizing everything, we need to understand that we have a completely different environment, and those different hydrodynamic forces are actually dictating the biology that develop on the structure. And it needs to be taken into account when we go into what we call ecological engineering of different structure. We need to identify key species, we need to identify the targets, ecological targets, and see how we can incorporate those aspects into the structure. And that's the meaning of ecological engineering, is actually create a mutual benefit for both humans and nature on structure that are functioning. And if we look at floating challenges, if we look at structural performance, longevity of the structure, drag and load and maintenance, all of them can be addressed in ecological engineering. We can harness forces from nature as bioprotection and accumulation of calcium carbonate by different organisms to affect the drug loads forces and to reduce flow resistance and also reduce maintenance in those structures. And it's all basically based on three aspects, key pillars, which is the material composition of the structure itself, what we build the structure from, the texture, the microstructure of the structure, and the micro design. There's other aspects that are very important to take to account when we deal with structure like that, and this is for example, accumulation of debris under those structures, overhangs and shading area. And I think one of the important things is habitat connectivity. And I think I'm reaching my end, but I want to touch one thing. It's floating structure is also an anchor and a connection system, and those need also to be addressed. And we published a few papers on the subject. And just to summarize, it's our duty to ensure that we develop an ocean in a sustainable manner. I think that ecological engineering is an aspect that needs to be addressed in all floating structures. There are very specific targets that need to be addressed in order to create structures that are work hands in hands with ecology. And the target is basically creating a win-win of infrastructure and biology. Thank you, everyone.
Thank you so much, Ido. Very interesting research results that I think will beneficial to all the participants of this conference. We have about 5 minutes for questions. I don't see any questions in the chat, but feel free to ask. There's one coming up now. So from Robert Jak, how long were these communities allowed to develop? And he has a remark with that. I can imagine that fixed structures experience higher exposure to waves, so they may be longer in colonization state, aren't they?
So it's really dependent. Yeah, it's a great question. It's really dependent on the depth. So if we talk at the water surface, of course, they're more exposed. But then on the other hand, they're, for example, they experience wave and they experience tides, which the floating units are not experiencing. And this dictating the biology and the biodiversity on them. So if we look generally at those habitats that are experience wave and experience tides, they will have higher biodiversity than the floating structure. It's really depend on your targets. The biology and the community that develop on floating structure is very, very limited because it's a steady state. They experience the same depth, the same elimination. It's very, very limited on the changing environmental differences.
Yeah, I hope that satisfies the question of Robert. Of course, I think one aspect that you mentioned, of course, maintenance, which is a very important issue to ensure the long-term efficiency, of course, of these systems. You also talked about shading area, which links into the questions of Robert Jak and Joost Lindhorst before, that the shading of waters will, of course, be a problem. What would be your answer to that one?
So there's a large body of literature on this. When we basically shading the habitat, we're changing the biodiversity in it because different species that are based on vision cannot utilize that. What we see is a peak in predators. Less juvenile fish can use the habitat just because of predation of those predators. So it's a major aspect that need to be addressed. For example, the Seattle seawall incorporated windows in the sidewalk in the Seattle waterfront in order to get light into the seawall, which then they started to see juvenile salmon using that habitat again. It's definitely something that needs to be addressed.
All right, thank you. And then there's another question. Is the community growth rate faster on concrete and other materials, or would it mostly depend on wave patterns, tides and currents? What do you think?
It's really a balance. For example, unpainted, untreated steel will recruit much better and more biodiversity than concrete. With concrete, you can modify the chemistry of the concrete to provide a better habitat and basically provide a better substrate and open the substrate for competition. And again, it's really dependent on a specific habitat, what will be most influential, if it will be the environmental condition or the substrate itself.
All right. Okay, and then the last question from Simon Richter. He's thinking about floating sculptures from Jason Taylor. And his question would be, are there ways of preparing the material of the structure to be more welcoming for organisms?
So there's this is a major question. So you can modify concrete. You can modify concrete to promote the growth of biology very efficiently, but it will not be in line with the construction standards and marine construction standards. It will not provide. It will not be with the specification. It cannot be in line with the design life that is required for floating structures, from load-bearing structures. So when you're dealing with load with concrete for construction, or that if you need to go with all the standards of the offshore industry and the marine construction industry, you cannot use those items. You cannot change the pH of the concrete. You cannot change different factors within the concrete mix. This is exactly what we do in our company. We modify construction-grade concrete to promote biology.
All right. Thank you so much, Ido, for all the questions. And I can't stress enough, as a researcher myself, that these research results are very important for a very positive implementation of floating structures. So thanks a lot. With that said, we go to the last but not least speaker, of course, Rui de Lima, that I would welcome to the stage. Original from Portugal, but doing research mostly in the Netherlands, but also Indonesia and Peru and other parts in the world. And his presentation is about assessing the influence of floating constructions on water quality and ecology. Or we close up. Yeah.
Hi. Maybe we can use some of this time maybe to ask direct questions at Rui on his topic, and we just continue with Anki right after. Well, at the scheduled time in 8 minutes from now. I think that is the safest today. Is Rui still online, or have we lost him completely?
I think we lost him. What we can do, just this is a short, Martin, if you allow me as chair, short about the visits floating structures with underwater drones all around the world, mostly in the Netherlands. He done extensive research with cameras and sensors to measure actually the effect of oxygen levels or other water quality parameters under floating structures. And he published quite some papers about it. So what we can do is, of course, to share his knowledge. I can put some of his papers or links to papers in the chat. Maybe that will help him. Because I think we lost Rui completely, sadly. So,
well, hopefully only the digital connection to Rui. I'm quite sure he's still there somewhere. Well, let's indeed put some links to his work on the chat. We could. I'm not sure if the first speaker in Anki's session is online yet. So let's see if there's any more questions for your session, Floris.
Yes.
Did we miss out on any questions?
Oh, people are ashamed to see Rui. Well, actually, we missed some questions in the beginning because my internet was quite slow, and that was on the. And I see indeed we could share maybe a video of Rui as well. That would be entitled to share my screen probably. I can address one or two questions that were in the beginning on Indonesia. Indeed, I presented some thoughts of Indonesia being not very enthusiastic. That's indeed the case, as the questions from Peter Ham and Stefan Huber were addressing. It's really a cultural issue, of course, and I hope that the best management practices that we actually share in this conference could help these things. What we could do is, are there any questions? Please put them in the chat about this session. That would be nice. And otherwise, has been suggested. Oh, there's a video link that Rutger is placing now.
All right, so I'll start the presentation. We already have a good number of people. Okay, so my name is Rui Lima. I work at Indimel, and I will present a work about assessing the influence of floating construction on water quality and ecology. Other authors of this work are Floris Boogaard, who also presented earlier today, and Vladislav Sazonov, who was a student that also helped us in this research some years ago. I would like, of course, to mention also the contribution of Rutger de Graaf, who you probably already know quite well by now. Miguel Dionis Pires, Janko, Hannah, and also Matthijs and Max were also students that also worked and contributed to this research. Indimel is a startup that actually was created following this this project. We do a lot of research, work a lot with research education institutions. We do, and we are specialists in water resources and using unmanned systems to monitor water quality. The results here shown are also part of a bigger consortium, as you can see all the logos in here. I usually start this presentation with a inspiring image, but you've seen this image several times, so I'll skip it. But just wanted to say that it's not a new thing. So in the Netherlands, you can find people living in the water already a lot along the canals, in the houseboats, but also more recently in houses with the floating foundations, and then sometimes there are already some floating neighborhoods, which we also did research in. As you all know, it has some advantages. You heard it from much more qualified people than me, but about the combined use of space, suitable for climate adaptation, all these advantages. But of course, it's important to also think about what the impact would be on the water quality and the ecology, which is still quite unknown. It's still difficult, for example, for water authorities, as Vicky was presenting about this as well, to evaluate if a project can be built or not. And sometimes many projects get hindered because of lack of knowledge, so the water authorities are lacking knowledge. By introducing buildings and structures in the water bodies, you're blocking the sunlight radiation, for example. You're changing the patterns of winds. You're introducing objects there that allow for biofouling to attach to and other organisms. So you're introducing changes. So it's important, in our opinion, to monitor those and to research what can happen, either by monitoring or by modeling. There has not been so much literature available about this. More and more, we see a lot of new works coming up. Especially now, because in the Netherlands also there's big plans for floating solar construction, so large scales floating panels on the water. And because of that, there's much more research and researchers looking at addressing this topic at this moment. So with this in mind, we wanted to collect data about these impacts. But then we ran into a problem. How would we collect data from underneath the structures? So there were some studies that they would get data from nearby the structure, but I never found information about what was actually happening underneath the structures. Then somebody had an idea of using an underwater drone that we equipped with sensors to travel under these floating structures so that we can get data and information about what was happening there. You could, of course, get divers to do the same thing, of course, but sometimes, even on top that they are expensive. Sometimes even the space under the structures and the bottom is quite small, so sometimes it's even dangerous for divers to go there. So if you use a submarine, then we could, without risks, get data from underneath. So that's exactly what we did. Here you can see a small schematics about our research. So basically, we went with the drones and near the structures, and then we sailed underneath it, and we usually stay there for a small amount, a certain amount of time, a few minutes, also to allow the sensors to stabilize. And then usually we also sailed further away from the floating structure to the open water to try to see if we can, to get some data to compare with, so we can see if there's some changes or differences between one place and the other. As I mentioned, we started this measurement campaign in 2014, so we've been busy with this for several years. As I mentioned as well, now more on the floating solar panels, but we did cover a lot of floating buildings like houses, but also some bigger platforms like the floating greenhouse, which I already saw in slides during this conference, and also the floating pavilion, which is a pity we cannot be there today. So here in the slide, you can see some of the drones that we used. So we started with the yellow submarine. That's the one that's in most of the pictures in this presentation. But we also, in the more recently, used more advanced ROVs, as you can see on the right. Some are bigger, some are smaller. We've also been exploring what we can do with these tools. You can see also a list of sensors and parameters that we can measure. In this presentation, I will focus on the dissolved oxygen, although we also have, it's also possible to measure nutrients and also algae chlorophyll. Here you can see an impression of the field work that we did, and also the calibration of the sensors that we usually do before. In the paper, you can also read more and see this table in detail, but you can see a lot of locations which are quite different from each other, either in size or when they were built, as well as the type of water system where they were deployed. You can also see in the map how these are all spread out throughout the Netherlands. So it's quite representative of the floating structures in the Netherlands. Here are some impressions of the houses that I'm talking about. So some of them are like holiday houses. Some of them are just regular houses where people live during the whole year. Some of them are more pavilions for events, or restaurants, also the case. So when we go with the drums to the water, and then we get them out of the water, then we read out the data, and this is the type of graph that we can make with them. So you can see, I think in the dark black, that's the variation of depth. So when we make dives, the drum goes up and down, we record the pressure. And as we do this, we can also see the other lines, other parameters that also increase or decrease. So this can already give you an idea of what's happening with the parameters. If we try to look deeper into the data, we made graphs like this one for the different locations, where we divided the data per depth range, which means that we're comparing between open water and under the platform data between within certain depth intervals. And what you can see in this image, for example, is that the difference are bigger actually closer to the platform itself than it is as when you go deeper. There are some explanations for this. For example, the water mixing or the currents or depending on the characteristics of the water bodies. So we did different types of analysis, also considering the trying to see if the amount of space under the platform, if that had an influence on the differences. And most of the results are quite varying a lot from place to place. So that's one of the findings. But of course, if you look at the dissolved oxygen between under and open, you can see in this graph that there is not so much difference. So you can see some locations it's a bit higher, sometimes a bit less. You can see there's a correlation just a bit above on the open water side. Usually show this graph as well, which plots the minimum values. So these are the minimum values that we measured from all these measurements that we did in the field. So you can see that in most cases, all the minimum values are always quite high, so above 5 milligrams per liter. There's one location in Amsterdam, the first one, where both open water and under the platform it's quite low. And there's one that's a bit shocking, which is in Delft, but we think this is a measurement error because the space under the floating platform is quite low. So I think we basically were entering, we're entering the sledge. We were measuring from the anoxic sledge, so that would explain why the oxygen is so low. If we look, we also had cameras on the drone, so we saw already some images. We have some more videos that you can see later. We have them online. So when we went under the platforms, in some locations it was very turbid water, but in some where the water was cleared and you could see environments like this. So you see a lot of fish, small fish. I saw that Bart Ruffen already mentioned in the floating pavilion that there are a lot of small fish, and that's really nice to see that they can use these sheltered areas to reproduce. And also these mussels, which basically by having a platform there create space for this type of organisms to develop, which could of course be invasive species or not, but in any case, in most cases, if there was no platform, there would just be an underwater desert, like I would also like to mention these two works, research thesis from that some students did, and under our supervision, where they also looked at other aspects, like Janko Lens, for example. He installed sensors that were continuously measuring data over a long period of time, so you could also see the variations of season and daily variations. Hannah Arkvig also made some transects, so you could see the different environments either under the platform or underneath the platform, and also looked at the benthic ecosystems and analyzing species. This graph showed some also models that we made for the light penetration, so that's something we're looking into now. So I already highlighted some of the conclusions. So there were some differences, but they are small, at least from the values that we are detected in these different water bodies and structures. The minimum values that we recorded are in general quite reasonable. The water body itself and its characteristics, seems to be quite decisive factor. And of course we only measure it one moment of time, so we do not take into consideration the seasonal variability. As future research, I would recommend, we need basically more data for longer periods, and also combine it with water quality modeling. And I would also like to highlight the part of the opportunity of creating ecosystems. So I have a few slides about that. So that we, together with floating structures, that we could recommend some practices so that also ecological measures to improve in the enhanced ecosystem can be deployed. It could either be for water treatment, just to enhance the habitats, even for wave protection. And also there are still some questions regarding design that should be addressed in future studies, like what are the optimal platform density ranges, the coverage, how much of the water body should we cover, how could we minimize the blocking of sunlight, which materials to use, so all aspects that should be discussed. So it's a good thing we are in the conference to do exactly that. Here's an impression that we made for one of our studies, just to show how a floating structure could look like with a strong interaction with all the surrounding environment, either fish or bird. As I mentioned, you can look at some more videos in Climate Scan. Floris already presented this earlier today. Also a good database for floating structures and also other relevant climate-related aspects. And as I mentioned also, we're now looking to the floating solar parks. We're setting up a consortium to look into this. There's already a lot of research going on about this from Blue 21, for example. And yeah, we also made some dives already from underfloating platforms. We also got some similar images of the biofouling. Yeah, and this structure, for example, it was in the water for less than a year, and you already see all these biofouling and mussels attached to it. Finally, I would like just to quickly mention the added value of using drones to monitor water systems, because it's a cost-efficient way to make maps of water quality, for example. There's still some challenges, but we're working on making them better so that we can improve the reliability of results and how cost-efficient it actually is to make water quality scans. I also have a huge library of pilot testing with drones that we did in the past, and I'm happy to discuss them with you if we happen to cross paths in this conference in the network moments. You can see a lot of work on developing drones. So to discuss a lot of opportunities. And we also do work internationally in Indonesia, Mali, Vietnam, and Peru. Also eager to discuss that with you. So that's what I had to say. I think I made it quick so you guys can still have a bit of coffee left. So that was it. Thanks for joining, and hope to see you around in the conference. Do you have any questions? I see some questions written here. Yes, that's a good. I see the question from Robert. Yes, we did more or less in the same period. So most of the monitoring that we did was around spring, so May to June, something like that. But yeah, definitely that's something I mentioned, that it's as a future research, we should really have fixed sensors. We're actually doing that at the moment. Under the floating pavilion, right now we have installed some sensors since we have easy access to it. And we are measuring data there, so we will look into that. I see a message from Joost. You're welcome. Okay, any further questions? I see a comment from Bart. Yes, indeed. The comparison between open water and under the platforms, that was all data from the exact day. So it should be the same. Any more questions? No? Okay, well, I think I will close this session then and make sure you guys still have time for networking. And any questions, just feel free to contact me in this platform and we can discuss it further. Right? Thank you.